This is section 13.2. We're going to talk about relative extrema. Now, a function has a relative extremum, and so relative means local, not the absolute extreme, but a local one. At C, if it has either a relative max or a relative min there. So, let's look at this picture. We've got this curve going like this, and it has a relative max at x1 and at x3, because on either side of it, it's going down. So you're coming up, and then you're going down. So you've got a max. Same thing here. It's got a relative min at x2. You're going down, then you change direction, and at x4. So, if a function has a relative min or max at C, then C is a critical number, or C is an endpoint in the domain. And we've kind of looked at that a little bit in the last section. The first derivative test, which we were using, said let C be a critical number for function f, and it has to be continuous on an interval from a to b and differentiable, except possibly at C. And then f of c is a relative max of f if the derivative is positive. So it looks like this. That means when you're looking at f prime of c, it's positive here, it's negative here. If it is this picture, then it's a relative min. So that's what we're going to do. There's really not too much new in what we've gotten from our notes, but let's go look at our problems. Okay, the first few problems, not a lot of work. Again, we're analyzing, and it may not be exactly like this in your homework, but it's generally the same idea. Find the locations and values of all the relative extrema. So what it says, it has a local, you decide max or min. So this has a max of, and when it says of, it means it wants the y value. So it wants, what's the local max here? It's at a y value of 1 at x equals -2. All right, number 2. Same idea. This has a local min or max. Okay, so this is a min, and the y value there is 1. So that's going in that box at x equals 2. Again, just analyzing the picture. Number 3 has both a max and a min. So you have to be careful, because here they're already telling you what the max is. What's the y value there? Well, the y value of 0 is right here. That's a local max at x equals 5. This is a local min of -2, y value is -2 at x equals 7. This one says find all the locations and values of the relative extremum. So we're looking here. We got a min here, a max, and a min. And so a local min of 0. Remember, when it says of, it means what's the y value there? 0 at x equals -5 and at x equals 5. And a local max of 625 at x equals 0. All right. Now, number 5. This one you have to read carefully and think about what it's asking and what you're seeing. This graph below is the graph of f prime of x. This is the derivative of your function, not the original. Find the locations of all the relative extrema and tell whether it's a min, max, or a min. So the critical number occurs where f prime of x is equal to 0. So remember, this is y equals 0. So we have 2 points where f prime, this function, is equal to 0. It looks like that's at x equals 3, and that's at x equals 7. Now, we have to look at this piece when x is 3. This is positive up here. So on the left of x equals 3, we're positive. To the right of x equals 3, we are negative. So that means in the original function, we have a max. Over here at 7, to the left of 7, we're negative. We're negative. To the right of 7, we're up here in the positive area. So at x equals 7, in the original one, we have a min. So our answer is here at D. The function has a local max at x equals 3 and a local min of at x equals 7. And you have to just think through that, knowing this is the derivative. These are your critical numbers where it's on the x-axis, and you're looking to the left and to the right of it to see where your positives and negatives fall. So it may be helpful to draw that out like that. All right, number 6, find the x values of all the points where this has relative extrema. So it wants us to get the critical number, find whether it's a max or min, and then what is the relative max or min. All right, so here's our function. We're going to first take the derivative of it. We get 2x plus 3. We're going to set that equal to 0, solve that. So 2x is negative 3, x is negative 3/2. There's our critical number. Draw your line. Put x equals negative 3 here. This is either from negative infinity up to negative 3/2, or you could write it this way. X is less than negative 3/2. X is greater than negative 3/2. You have to do a test point. So if this is negative 1.5, I tested f prime of negative 2. Greater than negative 3/2, I did f prime of 0. And when I plugged that in to the derivative, to this one, I got negative here and positive here. So that's telling me, if I kind of do that, if I do, oh, that's falling, that's negative, then it's positive, that looks like a min. So I have a min at x equals negative 3/2. The value of the min, I plug in negative 3/2 to the original function. So I'm plugging it in here, and I get negative 29/4. So I only have the min, and so I'm going to put here, and it says type an ordered pair. So you would put parentheses, negative 3/2, comma, negative 29/4, close your parentheses. So this will be an ordered pair here. On this one it says type in if there is no solution. Now I don't know on your actual problem, it could be a pull down where you have a choice that says there is no max. Whatever, you need to look for that because you know there is no max to fill in here. And you'll just, if it were like this, you would type an in here. This one you would put the ordered pair. All right, number 7, same thing except our original function is a quotient. So when we have a quotient, it's best to start with a road map. So g prime of x is equal to the bottom times the derivative of the top minus the top times derivative of the bottom all over the bottom squared. So I'm going to kind of work on the top, and then I'll come back to put it on the top of this bottom part. So if you see that I didn't put this on the bottom each time, I'm just waiting. So I took the derivative here. That was 2, chain rule, 2 times that, times the derivative of that, which is just 1. So that didn't really affect anything. The derivative here is just 1. So in this line, all I did was take the derivative here, the derivative here. Then I went ahead and distributed this, and this just became, and then I went ahead and expanded this binomial. So that's x squared minus 8x plus 16. This one, you go ahead and multiply, FOIL those out. You get 2x squared minus 8x minus 10x plus 40. I distributed the minus in this step. And then the only thing I did in this last line was combine these two. All right, so now I've got all of this. I'm going to collect like terms, and I end up with x squared minus 10x plus 24 all over that squared. I'm going to take that derivative, set it equal to 0. When I multiply this to the other side, that's gone. So now I have this is equal to 0. Factor that, x minus 6, x minus 4, and you end up with x equals 6, x equals 4. Those are critical numbers. I put my line, I put 4 and 6 in order. So here's x equals 4, here's x equals 6. This, if you define the intervals, either you could have negative infinity up to 4, or you could just say x is less than 4. Here, x falls between 4 and 6, and here x is greater than 6. Then you're going to test points in those intervals. Remember, it's f prime of something because you're going to plug into the derivative that you found here. So f prime of 0, f prime of, I did 4.5, and 7. I got plus, minus, plus for the things that I did. And so I know that here, if that's positive and that's negative, I have a max at x equals 4. I have a min at x equals 6. When I want to find the actual max and min, I've got to plug into the original. So I am plugging in way back up here, plugging into that to figure out what f of 4 is and f of 6. So when I do that, here are my x values, 4 and 6, 0 and 4 are my y values. So my max is here, my min is here. And let's look up at the problem. Let's see. You do have two different things, and they do just want an ordered pair. So put those in the correct things. So those are the regular problems. And then we do have an application problem that didn't print in that problem set. Let me go here. And this is one that you will probably see on the test as well. So this is worthwhile to look at. So this says the total profit, P of X, in thousands of dollars from a sale of X thousand units of a new product is given by. Now your function says ln of, and then it has this polynomial in here. Out here it says that X has to fall between 0 and 10. So those are some domain restrictions. That'll be important in the problem. Find the number of units that should be sold in order to maximize the profit, and then what is the maximum profit? So all they're asking us to do is what we've been doing, and we're just, instead of an ordered pair, we've just got two parts. So P prime of X is, when you're taking the derivative of ln, it's 1 over this times the derivative of what's inside. So the derivative of this is negative 3x squared plus 6x plus 72 times 1 over this. So ultimately this piece over this piece. That's your derivative. Now, we're going to set that equal to 0. When we do that, this piece on the bottom can multiply all the way over here, and it's gone. So we are left strictly with this. We're going to have that equal to 0. If you divide, I look at this and see that 3 goes into all those numbers. So if I divide by negative 3 all the way across, I end up with x squared minus 2x minus 24. That factors to minus 6 and 4. When you solve it, you get x equals 6, x equals negative 4. But remember, here's our domain restriction. Negative 4 is not in there, so you don't have to fool with negative 4. We just have x is 6. So we have x is 6, and it can only be 0 to 6 or 6 to 10. That's our restrictions right here. All right, so we have x is 6. This interval is 0 to 6. This interval is 6 to 10. So we're going to try f prime of 1, f prime of 7. We get a positive number here, a negative number here. So we are looking, so this is a max. So 6 is the critical number, and it says, let's see where you're going to plug it in. Let me look. Okay, I may not have printed that, but A part says find the number of units. Well, the number of units, X equals 6, but it's in thousands because it said that right here, X 1,000 units. So 6,000 units we have to sell to maximize the profit. Then you're going to plug in 6 into the original to get the Y value of the profit. And the original, again, is here. So I'm going to plug in to ln of this. I plugged in 6 everywhere there was an X. And when you do that on the calculator, be sure that you're doing ln, you hit parentheses, then do your plugging in. Put it in exactly like I've got it here. You should get 5.784 around, approximately. And the profit is in thousands of dollars. So we're going to move that decimal 3 places to the right, and our final answer should be the profit, $5,784 if you sell 6,000 units. So those are the 2 parts of that answer. And again, I think you'll see this type of question on your test. So be sure that you have gone over that one as well. I think that should do it for 13.2.